So, hello everybody. Now the seating plan. Now, I have to work it out. Jean-Pierre, you're at the end.
Okay.
Please.
Hello. Hello.
Bill, I can't remember who's next. Is it? Do you want Chieko there or Bill? Yes. Okay. So, Bill, you're here.
Okay. The middle one.
In the middle one.
Okay.
Mr. Uchiyamada, please here. Yeah. Thank you.
Okay.
Okay. Please sit down, please, everybody. Okay. So may we begin? May we begin? Yes? Oh, thank you very much indeed. Hello, everybody. Nice to see you. I'm Adam Smith, and I have the pleasure to be the moderator for this discussion. Now, this discussion is focused on mobility and accessibility. And I'm very lucky to have four wonderful panelists. Starting at the other end of the line, we have Jean-Pierre Sauvage, who is 2016 Nobel laureate in chemistry. Chieko Asakawa, who is an IBM fellow, William Daly, who is chief scientist at NVIDIA Corporation, and Takeshi Uchiyamada, who is chairman of the board of Toyota Motor Corporation. Now, this is an interactive discussion session, so what I'm aiming to do is to generate a discussion, a conversation between my four panelists, and also with the audience. So I will be inviting questions from the audience at a couple of points during the afternoon. We are going to have a couple of presentations during this discussion, very short presentations, and I'd like to begin today by asking Chieko Asakawa to give a very brief presentation on the need for accessibility. So, Chieko.
Thank you, Adam. Okay, so I lost my sight at the age of 14 by hitting my left eye on the side of a swimming pool. After that, I found there are two major difficulties to live as a blind person. The first difficulty was to access the information. In those days, there were no personal computers, no internet, no smartphones. Can you believe? I don't think young people can believe such a life. Anyway, so I couldn't read textbooks, magazines, newspapers, any book by myself in a timely manner. And another difficulty was mobility. I couldn't go to school by myself. I couldn't go shopping. I couldn't go anywhere by myself. I was very lucky because later I started working to change the situation. So thanks to the advancement of information technologies, the information accessibility has been dramatically improved. Maybe you are now look at the slide. So this chart summarizes the dramatic expansion of information resources for the blind, which I witnessed throughout my career, from paper to digital to the net. The changes may be quite similar for other people, not just for the blind, but impact on our lives was much larger than for other people. So two significant innovations changed the situation. First, braille digitalization. And another breakthrough was voice-based web access. Now we can get any kind of information through the web from all over the world. So the next challenge is mobility. How can we achieve such exponential growth for the mobility in the real world? Now I'm working for the mobility. When I walk alone in the city, I cannot recognize shops around me, products in the shop. If it looks delicious, if there is a long line in front of a shop, it's very important. And if my friend is approaching me, I cannot perceive all these visual information. 1 year ago, I showed the vision of the real-world accessibility using the short video. So please take a look.
Sound. can we turn the sound on? Just, yeah, pause it until we get the sound working. Is the sound, can we get the sound working on this video?
Murphy's Law.
You might have to narrate it, Jacob, but
Yeah.
we'll...
Should I continue?
No, just wait.
No,
They're just
wait.
checking the sound to see whether
No
it...
sound.
Okay, now let me show you the latest technologies. This is a smartphone app that we are working on.
51 feet to the door, and keep straight. Take the 2 doors to go out. The door is on your right. Nick is approaching. Looks so happy.
Oh, hi, Nick. Where are you going? You look so happy.
Oh, well, my paper just got accepted.
Oh, that's great. Congratulations.
Thanks. Wait, how'd you know it was me and that I look happy?
Hi.
Oh, hi.
He is not talking to you, but on his phone. Potato chips. Dark chocolate with almonds. You gained 5 pounds since yesterday. Please take that. Approaching. You arrived.
Okay, thank you. So the navigation app in the video is available on App Store, and it has been open sourced. And just early this month, we released a new version supporting the real shopping mall in Tokyo. It supports not just blind, but people with wheelchair and foreign travelers. So you can search for any restaurant shop on site using AI, both in English and Japanese. So if you have a chance, please enjoy. So anyway, I really want to deploy these technologies into the world. So I strongly believe we will soon witness the mobility revolution. Technically, everyone will be able to enjoy traveling in the city seamlessly and safely by means of cars, trains, by walk, and so on. However, there is a big challenge ahead of us. We need to change our rules. For example, detailed city-wide maps are basic data for the real-world accessibility. However, indoor maps are owned by each building owner, and there is no mechanism to create and share such map data. How can we create city-wide maps for pedestrians? As for self-driving cars, and actually there is a lot of discussion related to the self-driving cars this morning, but there are, required challenges are even larger, such as what can be a driver to be responsible for the self-driving cars? AI company, car company, AI itself? Of course, we need to build broad consensus for the new technologies in our society first. Then we have to define a set of new rules to enable broad adoption of the new technologies. Innovation and deployment are literally a pair of wheels. No innovation, no deployment. Now, Japan has a great opportunity to be a role model both for innovation and deployment in this AI era. I hope to innovate and deploy revolutionary mobility, accessibility for the blind, elderly people, foreign travelers, and everyone in our society, starting from Tokyo 2020 Tokyo, across Japan and to the world. Thank you very much.
Thank you, Checo. Thank you very much indeed. It was a lovely presentation. I'm particularly interested by this stress you place on the need for the community to embrace the technology as well, so that the deployment is just as important as the development of the technology. Bill, would you like to comment on that a bit?
Yeah, I think especially for self-driving cars, it is a community thing. I think right now the technology is ahead of regulation in that area. I think that under controlled circumstances, with well-mapped city area and weather within certain parameters, self-driving technology is here today. But two things are needed to move it forward. One is I think that society, the community, has to sort of understand what it is and what it isn't, what its capabilities are, so then they can support legislation or rulemaking that will let it be deployed. Otherwise, I think the regulation is likely to delay its deployment, which I think would be sad. It would, deploying the technology would save many lives, give a lot of people who otherwise wouldn't have mobility. It's a great thing, but we need to get ahead of it with the regulation and embrace it where it's appropriate.
I suppose that autonomous vehicles have the advantage that society likes autonomous vehicles, or the idea of them in general, and so it would be keen to implement such change, unlike, for instance, I don't know, biotechnology, when that came along, when people were a little afraid of it, and so getting society to make the necessary changes was perhaps a more uphill task. I'm not sure. I don't know.
Yeah, I think people do like the idea of self-driving cars, but I think very often they're afraid of what they don't completely understand. And so I think there's an educational component here to make people aware of what the capabilities are. Also, I think to fully deploy them in certain areas, you may want to pass rules that prohibit, for example, on certain roads, human drivers who would otherwise cause lots of troubles. And people may resist that change. They may be slow to give up the idea of driving their own car.
Checo, you mentioned particularly this question of building maps and the fact that they're in the private domain, but they'd need to be in the public domain for this to work. And you've obviously thought about that a lot. What is the likelihood of those maps becoming public?
You mean the light? So actually, roadmap is available, right? So people can develop a car navigation system, but the problem is we don't have a pedestrian accuracy level of maps yet, and also indoor maps like a building. So to create the full navigation system, both supporting outdoor and indoor for the pedestrian, we don't have any mechanism right now. So we have to create a worldwide standard, and people start following the rules. I know it's going to take a lot of time, but we should be able to achieve.
Yeah. And even roadmaps actually aren't publicly available yet. The very coarse roadmaps are publicly available. But for self-driving cars, you want very accurate roadmaps too, the centimeter accuracy with every curb plotted, every lamppost, so that the car can register itself against those.
Right.
And various companies have acquired that data themselves and don't share it.
Oh, yeah.
Okay. So what's the hope for the fact that it will become public?
Well, I think the word community comes to mind here, and that you would hope that there would be a community process to pool the data so that everybody can benefit from it. But where people see competitive advantage, they're slow to do that.
Right. Okay. I want to move on to the second presentation soon, but I would just like to ask the audience whether anybody has questions specifically about this question of accessibility for disabled or elderly or groups who would benefit from the sort of technology that Checo was talking about. If there are any questions, great. If there are not, we'll move on. I don't see any hands raised.
Maybe I have a question.
Oh, good.
To Checo, I'm sorry. So just updating the maps, I mean, isn't it a problem? Because it will have to be updated all the time.
Oh, but this is where sort of the cars can crowdsource it among themselves.
For cars, it
every
should be
time
okay.
the car goes by, it acquires new data, it pulls that, and
But for pedestrians,
hopefully the pedestrians will have sensor suites and they can be doing the same thing.
But we need to develop a new mechanism.
Yeah.
Okay.
Okay. But I guess, I mean, I guess the question of ownership comes into it, because if you, I don't know who, I mean, I suppose the city owns the roads, and they don't mind people making maps of them. People who own the inside of buildings maybe do mind somebody mapping the inside of their building.
Yeah.
So.
And there's privacy issues. I mean, if part of your acquiring the map is taking photos of, the fronts of buildings, you're also photographing who's there, whose car is parked, and people may not want you to know all those things.
Indeed, it must be a burglar's paradise that you can navigate inside buildings and see your route through them. So, this is a very, very complex issue. Gosh. Okay, let's go on to our second presentation, please. So, Mr. Uchiyamada, if you would talk to us about your vision for the future of autonomous vehicles.
Yeah, thank you, Adam. just we are very fired about the automated vehicles. So I'd like to express our vision for automated technology and future mobility. Please see, watching the slide. Before starting my presentation, as you know, every year there are 1.2 million traffic fatalities all over the world. In Japan, nearly 4,000 fatalities. In particular, we often hear about elderly drivers getting into fatal accidents. My heart aches for these sad events. I'm already 70. I don't know how much longer I will be able to drive a car myself. I think that automated driving technologies have the potential to help resolve issues related to safety, the environment, and freedom of mobility for many elder people. The development of automated driving technologies is currently the highest priority of the advanced R&D and engineering company. Through automated driving technologies, we want to help achieve a safe and accident-free society, and also keep accessibility for all people with reduced mobility. We have defined the direction of automated driving technology development under what we call the mobility teammate concept. Following the mobility teammate concept, we are aiming to construct a friendly relationship between the driver and the vehicle. This concept gives drivers the freedom to enjoy driving themselves while maintaining the choice of safe automated driving is required. We have identified 3 types of intelligence required to support the mobility teammate concept. 1, driving intelligence. 2, connected intelligence. And the most important thing is interactive intelligence between the driver and the vehicle. Interactive intelligence is the core technology for building a teammate relationship between the driver and the vehicle. We envision automated vehicles using 2 driving modes. In the first mode, the vehicle can select route and drive safely to the destination by itself. We call this chauffeur mode. In the other mode, the vehicle provides constant support to the driver while he or she is driving. We call this guardian mode. We are aiming to develop vehicles that can be driven safely and enjoyably by switching between these 2 modes, depending on the situation. Finally, I'd like to show you my dream.
Hello, Lori. Want to go for a spin? When we first met, we didn't know much about each other. But that would change as the years went by. Okay, Lori, what helps humans see in the dark?
Rods? Yes!
Why is there a blind spot in the human eye?
Because humans don't have eyes in the back of their heads. Oh no.
Of course, some days were better than others. And other days, life turned against her. How about a little trip? Beautiful, isn't it?
Thank you, Muse.
You're welcome. Lori. Ben, wasn't it?
What?
Lori, you're blushing.
No, I'm not.
Yes, you are.
No, I'm totally not.
I must say, Lori navigated her life fairly well thereafter. Well, of course, with a bit of my help. I don't have a blind spot like you do.
Hey, buddy. Where'd you come from? Muse, let's go home.
Don't you think Buddy needs a little workout? I know an excellent park.
Want to go to the park? Muse.
All right. Peekaboo, 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 peekaboo. When we first met, we didn't know much about each other, but that would change as the years went by. Lori? 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 Aren't we gonna go for a drive?
We're gonna do much more than that.
How do you feel it? Yeah, thank you. This video shows the possibility of artificial intelligence itself. And we, Toyota, will continue our effort for safe, smooth, and unconstrained mobility for all. Thank you very much.
Thank you. Thank you. Okay, there's a number of points to draw out of that presentation and the previous one. Again, Bill, may I come to you for an immediate reaction to that vision of the future of autonomous cars?
Well, I want to sign up for it. I would love to have a car like that that would sort of anticipate my every need and suggest destinations, sense my mood, and the like. And actually, I think much of it is within reach, although some of it I think still is far off. I think one interesting concept, and it was also in this presentation, is this notion of augmenting the human. And rather than replacing a human, the artificial intelligence increases perception, whether it's basically seeing things and then communicating orally what it's seen, or in the case of the car, being the guardian angel and seeing the dog behind the car, or seeing when the driver is getting drowsy. In NVIDIA, we have a technology called Copilot, which is very much like that. It basically watches the driver, senses their gaze, senses their level of attention, and helps them drive the car rather than completely taking over. So I think augmenting humans is a big aspect. You can make something better than either an artificial or natural intelligence by combining the two.
I was very struck by the relationship between the human and the device in both, if device is the right word, in both videos. I mean, it was more than just augmentation, because it was also being a kind of advisor. In Checo's case, it was telling her that she shouldn't choose something because she might gain weight. In Laurie's case, in the video, it was becoming a bit of a sort of life guru, the car. Do you see that that is also being part of it? This relationship beyond it augmenting your abilities, it's also participating in your life. Yes, please.
Yeah, as we discussed, that we are now facing the new era when we were introducing the new technology, it's a very difficult to make some consensus around the society. Automated vehicle and artificial intelligence and robotics, everything have a new step for the humankind. Because our action process is consists from the 3 points. One is recognition, and second point is a decision, and third point is action. This is a process of the action. Today, the decision made by the humankind, and sensing and actuation is supported by the machine. But now we are faced that decision process due to the computer or machine. So we need new acceptance or guidance or but it takes a long time. So, but before that, as I presented, we have to machine-man integrated system supporting each other. Yeah.
Yeah, no, I think the two aspects of it are very complementary. I think on one hand you have the self-driving technology, which is really perception and control. You know, you're perceiving the environment through video cameras and radars and lidars, and you're controlling the vehicle to give a safe drive both to the people in the car and those on the outside. But I think orthogonal to that is this notion of an intelligent assistant. People have very complicated lives. You'd like to have your artificial intelligence know what things are important to you, what your appointment calendar is, how you prioritize things. It can filter your phone calls, filter your emails, and you know that's sort of the life guru part of it. It may be more of just a good executive admin part of it, but it's something that everybody could have, not just those people with executive admins.
Imagine another thing is it will know how you drive. So when we think of autonomous vehicles, are we thinking of a uniform sort of autonomous vehicle, or are we thinking of autonomous vehicles that actually represent our different personalities? And some will be rather aggressive and nasty, and some will be rather polite.
I don't know that would work. I think one of the real promises of automated vehicles is that they'll increase utilization of the highways a lot by having cars operate much more cooperatively rather than having somebody trying to get ahead and weaving in and out of traffic. They can follow each other at centimeter distances because they have reaction times that are orders of magnitude faster than humans. But to have that work, they all have to drive the same way and cooperate.
Interesting. Do you see, and how do you see societal acceptance of that idea?
I think it's, people have to weigh, what's important to them, what the benefits are and what the costs. And I think the benefits will be, less congestion on highways, getting to your destination faster and safer. And you'll have to give up a little bit of personal control for that. But I can't imagine anybody wanting to get there slower and more dangerously. And so I think they'll be willing to give up that control.
Yeah.
You said, Bill, that you thought that basically the concept, parts of the concept weren't so far away. So what is the state of autonomous driving today?
I think like I said earlier, I think in a well-mapped area, in good weather, so not heavy rain, not snowfall, not fog, where you might obscure the effectiveness of the sensors, it's here today. I've had rides in our own self-driving. NVIDIA has a fleet of self-driving cars, one both in New Jersey and one in California. I've ridden in those. I've ridden in the Google self-driving cars. And I've been on complicated trips where bicyclists have come in front of the car, where there was difficult traffic, people acting erratically, and the cars handled it beautifully. I could also see on the screens that they were seeing things I couldn't see. As a human, I can only look in one direction at a time. If I'm checking this mirror, I'm not checking that one. It's looking all directions simultaneously. It's tracking every pedestrian, every cyclist, every automobile, every motorcycle. It's anticipating where they might go. It's plotting their possible trajectories. And so it can be, it has the capability perceptually to be far better than human. It has much faster reaction times. And under these controlled circumstances where the sensors work well and you have good mapping data, it's there today. And I think over time we'll extend its capability to, all sorts of weather. Quite frankly, people shouldn't worry about the weather. There's some weather when nobody should be driving, and to places where the mapping hasn't been done as rigorously, and that will come with time.
Please. Oh, yes. Checo.
So may I ask a question? So I think we have been discussing that self-driving car is going to help a human driver drive better, or can we also expect self-driving car without a real driver?
I think the answer is yes.
Yes.
Yeah, and so I think, first of all, I have parents that are in their 80s, and I think that it will give them a lot of mobility in a much more safe way by augmenting their abilities. So they can drive, but they may not see as well in their peripheral vision as they once did, and it will help them by augmenting their sensory perception. But I think ultimately it will be to the point where you can get in the car, and this is the case in these controlled environments. I've done this in both the NVIDIA and some other manufacturer self-driving cars. You can get in the car and tell it, take me to Starbucks, and it does.
Yeah.
Or in the case of Laurie's dog, it can get in the car and say, take me to the park for a walk.
Yeah. Except it can't talk.
Except, no, the car would understand.
Yeah.
But, sorry, Jean-Pierre, you wanted to come in?
No, just, I think it's a great project. I'm sure ultimately, everybody will be totally enthusiastic about that. I think of some drivers I know in Europe, driver education is going to be a key issue. The people will have to be disciplined, friendly to each other, mutual respect will also be very important. And there are some parts of the world where the normal drivers are not really ready to do that. Maybe also in the US, in some cities in the US, in the south of Europe, in France in particular. So this is why, I think that education will be really very, very important.
Yeah, or regulation. You may simply say there
regulation
are
or education
that no humans can drive on. You only let the self-driving cars on.
You're right.
Yeah.
Yes, Mr. Uchiyamada, please.
Yeah. Automated vehicle provides 2 points. Benefit is 2 points. One is reducing the traffic accident.
Sure.
Yeah? As I mentioned, around the world, 1.2 million people killed by the traffic accident now. And the second benefit is to provide freedom of mobility for every people.
Sure.
So, Asuka-san mentioned that our ultimate target is a full automated vehicle with no driver. But actual introduction to the market of such a vehicle is step by step. And first step is maybe a highway, very easy for vehicle to recognize the condition of the infrastructure. But as you can easily understand the Asakusa or a very crowded area, it's very difficult for the vehicle to recognize the situation. So we introducing step by step to,
I'd like to talk a little bit about the timeline for introduction because, there's a huge expectation, but there's always a huge expectation that technology will deliver. And obviously, the car companies and others are moving aggressively to try and make this work. But Jean-Pierre, perhaps we could start with you. You were awarded the Nobel Prize last year for a piece of basic chemistry.
Right.
And I guess the question you get asked more than any other is, okay, when can we apply it? When can we make something of this?
Yeah.
So,
well, I think it's a very good question, no doubt. Although, it's very risky to give a precise answer. I will take an example, which is not so much the work we have done in my group, but in one of the other laureates, my co-laureates, Fraser Stoddart, who is originally from Scotland and who became American maybe 10 years ago. He works at Northwestern University near Chicago. And they did some brilliant work in the field of computers based on molecules. And this is something I very briefly mentioned this morning. And they started their work in 2000, maybe in 1999, 2000. And in maybe 10 years ago, they published a very spectacular publication with several groups, many people, and they were able to store information using molecules and molecular machines in particular, to store information, to process information. So just to make it simple, to write, to read, to erase, and write again. I mean, this is the typical system for, let's say, storing information. And their system in 2007 was really spectacular in the sense that the volume needed to store information was about 1,000 times smaller than using transistors, silicon-based computers, so very, very spectacular. There was a tiny problem, which turned out to be a big, big problem. In fact, molecules are not so stable, and when you switch, let's say, several times, maybe 100 times, it's okay, but 500 times, some molecules start to degrade. And so what you have to do at this stage is to go back to the library or think again with your group. And they decided that the main problem, the stability problem, should be sorted out by modifying the structure of the molecules. And I think this is where they are now, 10 years later, and it's probably going to take maybe 10 additional years before they have something which is stable enough that it can be operated 1 million times without degrading, and then perhaps it will be applied as an information storage and processing device. So it takes time. I mean, this is what I...
Yeah. In the case of the self-driving car, I think it's going to be much faster than the molecules. I think there are two timelines, and I would bet on the regulatory timeline being actually the limiting one. I think right now in controlled environments, so for example, if you wanted to license self-driving cars to drive in the city of San Francisco in good weather, you could do it today. The technology is there, and it's entirely a regulatory hurdle. We have a permit to run our self-driving...
It's never good weather in the city of San Francisco. It's always foggy.
No, you often have wonderful sunny days. That's just a myth.
Agree.
That's London that has that fog.
Oh, yeah.
I think you could do it today. We have a permit to run our self-driving cars. Google does. Many other companies do. Uber actually left San Francisco because they didn't want to submit the data required to get the permit. They didn't want to share with other people. But the permit requires that we have a human driver in the car. And the question is when they will, there'll be significant confidence on the part of, I think it's the public ultimately that matters, but reflected through the regulatory agencies to say you can now take the driver out. I think technically we could do it today. I think for the harder driving situations, places where a human would go today in foggy, snowy weather. I have a cabin up in the mountains in the Sierras, and I'll often drive up there in difficult conditions where you can't see the lines on the road because there's a foot of snow on it, and the snow is falling, and so a LiDAR would be confused by the reflections off the snowflakes. I think that's maybe 5 or 10 years out, but I think that we understand the solutions we need to get the perceptual problems to better than human performance. And so I think that it's going to be a 5 to 10 year timeline for very general self-driving on the technical side. The regulatory timeline could take much longer.
Presumably one potential effect is that the regulatory side is going to come down and say you shouldn't be driving in this sort of conditions, in this sort of road. So it's that will very much change the way the relationship with the car, if that happens.
Yeah. Well, they do that today with the human drivers. I was trying to get to my cabin a few weeks ago, and I got to a state police roadblock where they said you shouldn't be driving today, and I had to turn around.
And Checo, you mentioned 2020 Olympics here in Tokyo, and it's also a goal for you and for Toyota to release things in time for this. What will the autonomous vehicle look like that people find when they come to Tokyo in 2020?
Yeah.
That's a great
Do you want to answer that?
In Japan, as a national project, we collaborate with the other automakers, not only the automakers, but including the map maker. As you mentioned, the dynamic map is very important. But there is only one map. There is not. It's not a competition area. It's a collaboration area to make one very nice, excellent map. So, as I mentioned, that we collaborate together. And 2020, Tokyo Olympic Paralympic is a very big chance to show how the automated driving under the actual usage for the. We are now planning to introducing automated vehicle, but area is very limited on the highway and the Tokyo highway.
Will you have a human driver in the car? Or will it be completely autonomous?
I'm not sure, maybe driver for the some prevents for some accident.
I just want to check, does anybody in the audience want to ask a question? Please, there's a microphone coming.
Hello.
Please, could you stand up to us?
Oh, okay.
Thank you.
Hello. Yes, my question is more related to the fundamental question that are machines better at decision making than humans when driving cars? So basically what I would like to do is give you 3 scenarios in which there's a race, a F1 race, very high performance race happening between maybe say 10 cars. And the first scenario, it's only humans, just like we're doing right now. It's only humans who are doing the race. Second, it's only self-driving cars. And the third is humans being assisted by self-driving cars. In which of those races would we have the fastest car? And in which of those races would we have the least accidents? That would be my question. Thank you.
Well, I think it's clear that the fastest will be when you have the humans being assisted by the AI, right? Because the AI will do better than humans at the perceptual tasks of perhaps scanning the road surface and controlling the car to be very smooth on the control inputs and not start a wheel slipping at the limit of adhesion. But the humans are probably better at the strategic task of reading the whole race and deciding when to draft to save fuel, when to make a move to pass, and plotting the strategy. So I think if you have each agent doing it what they're best. But I think a race is actually a very artificial and constrained environment. It doesn't reflect day-to-day driving. I think that when people look at what they're worried about with self-driving cars, it's what happens when there's an accident. And I think there are 2 real advantages you get with autonomous vehicles in that case. The first, maybe 3. The first is they don't have the inattention problem. A very enormous number of accidents happens today because people are trying to multitask, or they simply are daydreaming. They're not paying attention. They don't see the car stopping ahead of them, and they plow into it without braking in time. The self-driving car won't do that. In a case where something unexpected happens, somebody runs a stop sign ahead of you, they'll have, it won't be just reacting. People will often react. It's basically no time to think. They see something happen, they'll hit the brake or they'll swerve, but it's not a thoughtful process. The car will have programmed into it hundreds of scenarios that it will match to this situation and have, by some measure of optimality, the optimal response to that. So I think in these real-world situations, autonomous vehicles will give you much better responses to emergency situations than you would have with a human driver.
But, sorry.
Yeah, most situations, the machine is more skillful than a human driver, but very limited area, machine cannot recognize the situation or also control the vehicle. As you know, that today already the airplane and the ship installing the automated driving system, but they doesn't allow that there is no pilot or no captain. Yeah, and also people doesn't want to ride on their airplane. If the announcer said this airplane drive just the computer, no one want to ride it. So it takes a long time to full automated vehicles because the vehicle is more complex compared with the airplane and the ships.
But thank you for the question, because it leads me to a final question, because we've run out of time. This morning in his introduction, President Anzai raised the question of when AI, or if AI, might be awarded a Nobel Prize, and that is something we will visit in the next session and also at the end of the day. But as a final question to this panel, and Bill, I guess you've already answered it, but will there come a time when an autonomous vehicle is declared Formula One champion without a driver in it?
I think that probably has a lot to do with how they write the Formula One rulebook. But I think we tend to anthropomorphize these AIs. We tend to make them become human, but they're not. I remember when I was on the faculty at MIT, my colleague Rod Brooks once said that he really thinks AI ought to stand for artificial insect, or on his more ambitious days, artificial iguana. Because what they really are perceptual and control systems. And in perception tasks, basically, getting data from a number of sensors and detecting objects, tracking objects, classifying objects, they're better than human. And in the control tasks, because they have very fast response times, they close control loops and apply model-based optimal control and basically be more skillful than a human in controlling a vehicle or anything else. So I think if you wrote the rulebook right, you could win the Formula One today with a self-driving car. But I'm sure they'll write the rule book to prevent that from happening, because it wouldn't be so interesting for the spectators.
It's that question of control.
I agree. Yeah, because F1 is a competition between the professional. So it's very easy compared with the actual traffic.
Okay. Unfortunately, we're out of time, but it's been a lovely discussion. Thank you to all my panelists, and thank you to the audience.
Thank you very much.
Oh, it's a pleasure meeting you.
I enjoyed it.
Thank
My
you.
old colleague Gil Pratt works for
I forgot your role. Are you Sony Research Laboratories? Is that?
Yeah, Sony Computer Science Lab.
CEO.
Yeah, CEO.
Computer Science Lab. I'll just do it for the one thing. Yeah, sure. When do we start? Do we give it 1 minute or 1 minute?
Now.
Now, go. Okay. Hi, everybody. Welcome back. So, for those of you who have just joined us, welcome. My name's Adam Smith, and it's my pleasure to moderate this panel, which is on health and welfare. And I'm joined by 3 august panelists. I have Edvard Moser, who was 2014 Nobel laureate in physiology and medicine. Shahram Ebodalahi, who is, I'm sorry, I didn't look it up before I started, chief of the IBM Watson.
Chief Science Officer and Vice President of IBM Watson.
IBM Watson. And Hiroaki Kitano, who is CEO of the Sony Research Laboratories, Computer Research Laboratories. Computer Science Laboratory, I'm sorry. Okay. So, we are here to discuss the application of augmented intelligence to health and welfare. And I thought we might start with a discussion of the present and then move into a discussion of the future. So, Shahram, IBM have been doing an awful lot with Watson in current health research. Could you talk a little bit about what you've been doing and also perhaps extend to what other people are doing as well a little bit?
Sure, absolutely. First of all, thanks for having me. It's great to share the panel with distinguished speakers and panelists. So, and I want to thank you by starting by saying augmented intelligence, because that's exactly how we see it. It's helping the human actor to better perform what they need to do and better make decisions better at the point of decision making, being the doctor or nurse or the pharmaceutical research scientist or the patient themselves. So just to give you examples of what is in the market today and what is being done using some elements of augmented intelligence or what we call cognitive technologies, I want to point to 3 examples. One is a technology we call Watson for Genomics. And this was actually, for those of you who are coming from the United States, was showcased in the CBS 60 Minutes, one of the episodes 2 months ago. And it's about having the machine basically extracting from knowledge repositories treatment options that best match to a tumor genetic makeup. So this is actually an important task, because if you're the oncologist sitting at the tumor board trying to decide a treatment option or a clinical trial for this patient, you have to be able to read lots and lots of publications, scientific publications, that talk about a certain treatment or clinical trial and its relevance to a particular genetic tumor makeup. And you can imagine a physician, even the best physicians, probably they read 300 to 400 publications per year. There are 40 million scientific abstracts in medicine out there. So you can't expect any physician, any scientist, to be able to read 40 million scientific abstracts at the tumor board and decide what the right treatment options are for this particular patient. So it's a very good example of augmentation of the human actor with the machine, where the machine can read and sift through these 40 million publications, identify options or treatments or trials that can affect a certain genetic makeup of the tumor and suggest that to the oncologist sitting at the tumor board.
But presumably physicians have always had tools available which enable them to sift through past data.
Yeah, so today is, it's more than keyword searching, is understanding the relationship between concepts. Mm-hmm. So this trial or this treatment affects this pathway and affects these kind of genes, and therefore you want to surface that to the oncologist. We did a study at University of North Carolina, Chapel Hill, with 1,000 patients, where actually, for the validation of the technology, for 99% of those patients, the machine agreed with the human expert oncologist with respect to the suggestion of the treatment. Now, the interesting thing is for 30% of those patients, the machine suggested a treatment that the oncologist or the human expert overlooked. So that you want to then bring that to the attention of those oncologists, So it's a good example of scaling the human power in that particular scenario. Another case is what we call Watson for oncology. So by year 2020, there would be 26 million new cases of cancer worldwide, right? 70% of which are in countries that don't have access to the best cancer care, right? So the issue is how to democratize cancer care, how to put it in the hands of the people who are delivering cancer care, but they might not have the best tools at their disposal. So what we have done with Memorial Sloan Kettering Cancer Center in New York is train Watson, this technology, by the best available knowledge to Memorial Sloan Kettering scientists out of the trials that they have done, plus publicly available guidelines, for example, from National Cancer Center in the US or other places. But not only that, be able to read the medical records of the patient themselves. So going through the electronic health record, reading their medical records, and then reconciling between those two. If I'm seeing this patient and this is what their medical record is telling me, these are the preferences of this patient, and these are the knowledge or guidelines or guidance that public guidelines or Memorial Sloan Kettering guidelines are telling me, and then putting three options in front of the oncologist. One is green, this treatment is recommended for this patient. One is red, don't apply this treatment to this patient because this is not a good match. Or yellow, which is if you address these issues, then this treatment will become. So this is as if you are democratizing cancer care, learned at the best places, but democratizing it to the other places in the world. And there are many other examples, for example, Watson for Drug Discovery, which is now aiding the research scientists in the area of immuno-oncology and ALS that we are doing.
Okay, thank you very much, Sharam. Hiroaki, do you want to add to that?
Well, I think now the AI capability actually properly used, so again, depends on the AI, say the AI or cognitive computing, but, it's in diagnosis actually, we have a lot of things that we can benefit, for the patients. I'm engaging the government project called the Medical Hub project, Medical Innovation Hub project, which we talk to university hospitals and get the clinical data and apply unsupervised learning or deep learning, whatever it requires, and then actually try to get very in-depth patient stratifications, which doctor may not actually recognize, and then whether we have a new subcluster coming up, and we try to look in detail and see what are the possible biomarkers, or what are the difference between this cluster, this subcluster. Is a specific drug some pharma is developing is specifically for one of the subgroup, or both of them, or if specifically functional for the effective for the one group but not the others. What are the biomarkers? And I think that would make a big difference in terms of the efficiency of drug discovery and also the accuracy on the clinical diagnosis. So I think right now a lot of utilities of the machine learning, data analytics technology into the clinical diagnosis field, and I think that would be like a irreversible trends that I think that we are facing. Enormously benefit the patient. I think that's immediate things. I think that's huge.
Okay. Although I suppose as you segment patient populations, you then need a concomitant change in the regulatory structure, which allows you to deliver drugs to those segmented populations, because that is. And would you say that the technology was running in parallel with the regulation, or is one ahead of the other?
Well, I think one of the problems is that drug discovery pipeline, for example, like a pharma, is that many failure actually seems to be happening on the relatively loose patient stratifications. If they can stratify the patient much precisely, they can achieve the clinical endpoints relatively easier. But at the same, by the time they actually have select the patient, it is in a loose ground. The efficacy is already diluted. And then, so even if the most effective one is not going to be 100%, so it's, you have to subtract some, portions, and then you already diluted. Then it's hard to get the clinical endpoint. So if you have a specific biomarker, specific subcluster, I think the chances will be much better. But then usually, then a new trend is like a new compound go with the biomarker diagnosis system. So that's kind of a recent emerging trend. So you have like this specific immuno-oncology drug, and then they have like a specific diagnosis system, or the biomarker system, whatever it is, to properly select the patient. That works, or it's not going to work.
But there are all sorts of questions related to that about
Yeah.
market size.
The market size, yes, that's right.
Yeah.
Yes.
Edvard, may I come to you? In terms of very basic biomedical research, if you would, I don't know if you classify your own research as basic biomedical or basic biology, perhaps, but what is the role of augmented intelligence in your work?
I think it's getting a quite significant role, because one thing that has really changed in biomedical sciences is that, especially in neuroscience, is that some decades ago we had lots of questions, but we didn't really have the tools to address them quite directly. Now many of those tools are available, and we can actually read out the activity of thousands of neurons in the brain at the same time, at a very high temporal resolution. So it's so much data that we have access to, but now we have more data than questions. So it's actually trying to find structure and find out how the brain is working. We have the material there, but I think that artificial intelligence will play a quite significant role in looking for structure in such data, looking for patterns, but it can't do the entire job. So therefore I really like the word augmented, because I think humans are still, for quite a long time, needed to actually interpret. If you see there's a connection, for example, between a neural pattern and the behavior A, and another neural pattern leading to behavior B, you still don't know why is that happening. And I think that's not an easy thing to get a machine to do, at least yet, because you need to know so much. There are so many unknowns that maybe one day we can put it all together, but not yet. But I think data is one thing, and then the other thing, just to pick up on what you have mentioned too, is that there is such a growing literature. I mean, yes, millions of papers, and there's no one who can read over and have access to all of it. So there actually is so much information already out in the world that no single person can get access to. And again, if machines can help us with that, but I wonder, we may still not be there quite, because one thing is if we could feed data from a paper into a computer, yes, I would see that would be helpful now. But to have a computer read a paper and actually understand what is said, I would think is a much harder task, because whenever, at least I read a paper, I can read a paper in neuroscience because I read thousands of other papers before. But if it was a new paper, I would have no chance, even if I would understand the individual words. So I think there's a possibility, but it's still a way to go. But yes, indeed, I think artificial intelligence is already actually becoming a very significant tool to handle large amounts of data in neuroscience, or actually in all kinds of sciences.
Yeah, I mean, just to add to that, this issue of explosion of data. So he mentioned it in his types of research studies in brain, but in medicine, in health delivery, right now there are 160 exabytes of data only in health in the US, not the world. By some estimates, by year 2020, there will be zettabytes of data. I mean, forget about just storing this data set, making sense of this data and bringing it to the point of decision making is a huge task. And actually, at some point, it becomes scary, because if you're seeing a patient and you're facing with this amount of data and you cannot extract meaning out of it and be able to extract insights and bring it to the point of decision making, it's like practicing in the dark, if you will.
Yeah, for sure. But it seems to be a leap of faith to think that somehow that data could be brought together. I mean, for instance, even just getting to the point of having reliable electronic health records that can be transferred between hospitals is still a distant dream.
That is absolutely true. Of course, it's not a solved problem, but I think we are at the very early stages of this new era in application of augmented intelligence or to the area of medicine. because of certain policies, I mean, in certain countries in the world, that has been solved already. There is a country-level electronic health data exchange happening. From where I come from in the United States, because of implementation of certain policies, increasingly electronic health data are becoming available. Yes, there are in silos. There is no exchange yet, but it's going there, and we can expect it to happen. But if you look at the health data and determinants of health, only 10% of determinants of health are things that are captured in electronic health record. So in your clinical visit, you go to your primary care physician or GP, only 10% of determinant of health. 30% or so are genetic or genomics factors. More than 60% are behavioral, social, environmental, or the so-called exogenous factors. And this patient-generated data, wearable technologies, and so on, basically e-monitoring of patients, that data is also becoming available. So we are seeing the convergence and confluence of these different elements. Data will be available. As we saw this morning, the different speakers, the AI technology is at least at a level that we are seeing real application of it to the data. So these different things at this juncture in time are coming together.
I think we have a lot of data, omics and all the very advanced measurement instruments that are coming out. At the same time, what happened after that? We get data. Maybe we can have a cluster analysis or some sort of regular analytics, and then we start thinking, scratch your head, and what does this mean? And that's kind of like a pre-industrial era. We have to really think. And that part actually haven't changed much in the last I don't know how many decades. So the challenge would be to actually change that part. I think that would be really the challenge. So that's and then also as you mentioned now, that's kind of data overflooding. At the same time, there are kind of data which we haven't captured on the system yet. And so we bring that data. At the same time, there are too many data. And the other thing is knowledge we communicate. It's written in the paper. And it's a natural language. That's kind of lousy way of communication or describing things, actually. It's our cognitive limitations. I think it's a limitation of our scientific activity. And I actually created a very extensive molecular interaction map of the immune system, immune cell, or tumor-related signaling pathway. We read 2,000 papers. And then, right now, all the interactions are very much in detail. 10 years ago. Can't really update, actually. So no way we can do it but human labor, actually. They have to be automated, but the technology is not there yet. And so we have a lot of interesting challenges to come, and if we can solve all things one by one, things can be completely changed.
Edvard.
Yeah, I just want to add to that that's actually an interesting development that's taking place both in neuroscience and presumably also in many other sciences now, is that only a few years ago, and maybe even today, most laboratories actually store their own data for themselves, and they remain in that lab, and they work on them alone. What's now happening is that people are trying to, making quite significant efforts to have everyone, in a few years, I will think, upload their data, their raw data, on computers so that they're available to people around the world with different types of questions, expertise, so that it will enhance the amount of data available to a quite enormous extent, I would think. So it will be a real transformation where everyone's suddenly sharing everyone's data.
So that's a dark data problem.
Yeah. But there's an unfortunate fact in the area of medicine, which is in the pharmaceutical industry, because of proprietary nature of the studies that they do, there is no such data sharing, at least not now. And also in electronic health records and what hospitals or university hospitals are capturing, because of the way the research gets funded, is having that data and being able to publish on it before you share it with anyone else is actually the fact, the reality today.
Well, I mean, yes. I mean, when you mentioned the pharma industry, I mean, there are steps towards it. There's open innovation.
Yeah.
So, but it's a very difficult change to bring about.
Yeah.
Do you think that they're going in the right direction?
I mean, so I think one of the interesting things that is happening right now is this concept of patient-owned or patient-mediated health data. Because again, of some policy changes that are happening or have happened already, is putting the patient data in their own hands and based on their consent, sharing it with various actors and users of that data or whomever is providing the service. I think things are moving in that direction, but at least at this stage in time, we're not there. But I think we will get there. So in scientific studies, especially what Professor Smoot was talking about in physics, a lot of the advancements have happened because of the sharing of the data. And if you look at the publications, there are 40 people on the publication on the author list. That is because a lot of sharing has happened, and that collaboration really is advancing the state of the science in that. In health, I hope that happens. The indications are that it's going that way.
Okay, good. Thank you all very much. Now, I do want to have the possibility for people in the audience to ask questions if they like. Is there anybody who'd like to ask a question about the current state of augmented intelligence's role in health and welfare? If not, we shall move on to the future. Let's move. So, Hiraki, I'd like to come to you. You published last year a rather provocative paper.
Yes.
Setting a grand challenge for the development of an AI system that would basically become a systems biologist, grand scale, and would eventually be awarded the Nobel Prize for physiology or medicine, or chemistry perhaps. So tell us a little bit about your vision.
Oh, yes. I think this is a grand challenge. I'm not saying this is going to happen like in 5 years from now, like probably not 10 years. Maybe 20 years, people start worrying about it, I guess. So my goal is to actually set like by 2050 to develop the AI system that will make a major scientific discovery worth Nobel Prize, particularly in physiology medicine because it's hard. I think it's very hard. And the little bit twist of that is what I said, Nobel Turing challenge is committee may not be able to tell if that is the AI system or the human. That's kind of interesting part of that. But I think this is a kind of way we can push AI technology. In the past, AI has been technology pushed by the grand challenge. Initially, it was chess, and then the shogi, and the Go, and the Jeopardy, quiz show, and then now talking about autonomous driving, and then soccer games, and all that. So like a big challenge has been proposed, and then a global research community shoot for that. And this is another moonshot which I'm proposing. 20 years ago, I proposed to actually create a humanoid robot soccer team to win the FIFA World Cup by 2050. It's going on over 20 years. And then one of the spin-off is actually the application of the soccer robot to the warehouse management system, and now which is Amazon Robotics, actually. So we have a lot of spin-off, and then a lot of technology, accelerated. So what is this about this AI challenge for the Nobel Prize is how can we actually create the AI system which can actually make a discovery by itself? Okay, one thing can state is the AI system is good at finding the literature, finding knowledge which has already discovered, which has high value already. At the same time, but it doesn't really come up with a new knowledge we haven't discovered yet. And can we actually generate a lot of hypotheses, many of them reasonably legitimate, can go through the series of tests. At the end of the day, you might want to actually go for the experiments, probably robotic system as well, and then verify that. And how can we actually close the loop? And so I think this is a really interesting challenge. And then so one of the things is our lessons on AI in the past is that's directed brute force, lot of hypothesis generation, search, machine learning, and then they come up with the good move in a chess, for example. So maybe the scientific research may be not that different. We think we're doing something different than the chess or Go, but at the end of the day, if you think about a lot of knowledge in the world, the principle of the universe, or a lot of facts in the universe, if we actually generate a lot of hypotheses, for the instance of the hypothesis, and verify that, make it consistent, and experiment. So it's probably a direct search of the hypothesis generation and verification in a really remarkably fast space and a much larger search space. So then we'll see. I mean, if that is actually successful, that we will know something about a scientific discovery or maybe different forms of scientific discovery.
Yeah.
I want you both to come in on this.
Yes.
Edvard, do you want to go first?
I don't think this will happen within 2050, but what I would say is that I would have I would have a robot who could do these things in my lab for sure, because it's extremely useful. But I don't think he will get the Nobel Prize. I think maybe a difference is that I think artificial intelligence can, yes, extract patterns and even generate hypotheses and address them. Yes, but maybe where I would think it's lacking is still the ability to synthesize information into more than just a question, maybe into theory. So can a robot generate a theory and not only a hypothesis? That's very different, right? So I think that's still a long way to go, and I think partly because it involves what we often call creativity, so which humans are good at. I would think that you can also get machines to be creative by randomly putting together things, but still, I mean, when we are creative, it is because we generate the unexpected by combining maybe experiences, information that we collected over 50 years of life in quite random contexts. So I would think that's quite hard to reproduce. I would never say never, but I don't think it will happen within 2050.
So I think, can I just add on to that?
Please.
The interesting thing about this, like, our lab, my Sony lab in Paris, actually recently come up with the AI system that actually composes the music. And that's what we did actually is in this machines, the AI systems, we put like 14,000 scores, read seat. And what they actually come up with is this is the kind of abstracted style of the sound movement, which sounds like a music to human. Okay, and then sort of a human composer pick 45 Beatles song on top of that, and then the machine learned to extract the style of the Beatles, and then it generates a music which is not a cut and paste by any of the 45 Beatles song, but it sounds like a Beatles. So we're actually doing this. That's on the YouTube, so you can hear that. And then we created 10 different, very different style of music, and we had the first ever concert, all composed by AI, last October in Paris. And that's pretty good, actually. And what this means is actually AI actually abstract the specific style of the artist, and then actually generate according to that style. So that the question is, this is still the music, it's not scientific discovery. But now we come to the stage that we can actually not just like, come up with the combinatorial, learning things, but they come up with like some more abstract style extraction. So that means this machine is discovering the Beatles song, which Beatles haven't discovered.
But I think there is a main difference here. So if one could conduct a longitudinal study of Edward and other Nobel laureates who 30 years ago we didn't know Edward was going to be a Nobel laureate, right? And he didn't know it either. But if, let's say, we knew it, and we could conduct a longitudinal study and basically record everything that they did, every paper he read, every interaction he had, every discussion he had, maybe we could, if we had that data, maybe we could teach like what the composition of that the score by the machine. I think is a far too unconstrained problem in this particular scenario to expect the machine. I shouldn't be saying this because I come from an AI background, but I should expect the machine to be a Nobel laureate. I think, however, what is going to happen is create a problem for the Nobel Prize Society. The number of options or the number of people who can come up with a Nobel Prize winning theory would increase because now they're enabled by the computer, by the AI. They can do their discoveries faster, but they have to connect the dots. Because today, I mean, going back to the today versus tomorrow, we are generating hypotheses. So for example, with Barrow Institute in Arizona on the topic of ALS, we actually came up with 5 genes that it wasn't reported in the literature that they could affect ALS condition. But now basically research scientists took that in the lab, they verified that it actually is the case. So the machine, by connecting the dots, by creating these inferences between similarities of concepts in different silos that could be actually hidden to the human observer, can bring that type of insight and put it in front of the researcher. But again, a lot of the scientific creativity I think, is a mystery to the machine at this point.
But then in that case, it still depends on humans at some level telling the machine what to look for to find those 5 genes, isn't it? So which I think is maybe what is different from contributions that are more of the type that, at least some of the ones that are rewarded with the Nobel Prize, is that it's a much bigger, more original, or I mean, you do something that is completely different from what someone else or what others have done. So the originality, in other words, which is originality is probably the most difficult to reproduce. It comes also with the music. So because some of the best music, or let's say some of the best literature, is what is different from anything else. And you can't produce that by just learning from the past.
Yes, because how much of what is going on now, in the case of the Beatles song generation, for instance, is pattern recognition? And how much of science is pattern recognition? What is originality in science, creativity in science, different from pattern recognition? I don't know the answer to that question.
It could be the specific pattern applied to different domain turn out to be something very original. You know, if that is the case, like we might actually come to. So that, you know, the real point of this challenge is not whether this system will get the real Nobel, but like, can we actually really understand scientific creativity, and can we actually extract the past scientific discovery patterns, and if they're in style, and they apply to the other domains, are we going to discover something really original from our eye, but there's some fundamental discovery principle behind this? If that is the case, this system will enormously benefit, accelerate you know, the scientific progress. I think that's actually the real point of this challenge, actually.
Okay.
But I think you can, yes, indeed. I mean, pattern recognition is part of creativity, and especially recognizing, put together patterns from very diverse areas which haven't been put together. But then again, I think I can see easily how that can work for identifying a gene underlying a disease, for example. But I mean, making a new theory of how the universe evolves, that's something totally different, because it's so much larger scale, right?
I think related to that, one of the challenges is how machine can actually decide to choose a topic, actually. You know, because like, you know, what you know, topic subjects to study will great influence on the, you know, the impact of research. And if, you know, human can actually tell, or do this, probably machine will be able to do very well. And can machine able to weigh the value of the topic and then decide to choose it? So right now, I think like, you know, advanced chess, like humans and machine together, is way stronger than the machine alone or human alone. And one of the reasons is if a really good you know, human player in chess can tell machine where to search, because of the resource-bounded conditions, they much better, you know, deeper search on a specific area. So the human have to be very good. You know, then you can actually, you know, direct the constraint resource in the specific area, which is very useful. So I think the same thing will happen for extended period of time, even if you have very good hypothesis generation machines or scientific discovery machines. If a human can say, okay, let's do this. This is going to be important. I think that would be useful. Then the real challenge is probably after that, maybe 2050 or beyond. Can machine actually, you know, identify, or this has to be studied? And that would be the really challenging, actually. That would be the true insight, how machine acquire the insight. I don't know. I have no answer. But I think that would be a very interesting thing to think about in the long run.
So let's change the question slightly and ask whether the machine can become the doctor in healthcare. What do you think?
So I don't think so. So if I mean, define doctor. So if it's pushing the nurse or doctor, primary care or specialist of different kind to work at the top of their license and leave some mundane tasks to the machine, yes, it can happen, right? But I don't think if the machine can really take over from the human expert. So I think and we heard it this morning in one of the panels, I forgot which one. The societal aspect of it, the relationship is very important, especially in medicine. This medicine is, yes, a part of it is making sense of data, forming hypotheses, putting the patient on a certain treatment and observing what happens to them, and course correction. But a lot of it has to do with the relationship between that physician and the patient, right? I don't think that element of it will go away anytime soon. If it's a specialist physician who is doing a not very sophisticated task and you want to supplement them with and push them to perform at the top of their license, yes, that would happen. And I think that as we go forward, more and more examples of augmented intelligence in medicine, we will see that happen. But I think always it would be a symbiotic relationship between the machine, the augmented intelligence, and that physician actor.
I suppose more and more, though, we're seeing people avoid doctors and use the web of information that's out there to self-prescribe, to self-diagnose, and that surely will blossom, and there's a huge market there. So.
Absolutely. So this issue of consumerism is happening in health, and for various reasons that we don't need to go into. A lot of it has to do with policy. I think the utopia, if you will, in the area of consumerism in medicine is every micro moment of interaction that you can actually surface, a machine intelligence can surface an insight to help that person self-manage themselves with respect to adherence, with respect to other types of things that they need to do. And very importantly, in medicine, one of the biggest factors that is not being looked into, unfortunately, is bringing behavioral economics into it. What to do in order to stay on the right track and not to, because a lot of the waste in medicine is happening because people are not adherent to what is being suggested to them, either medication or care pathways. So I think using those micro moments, bringing artificial intelligence, identifying those micro moments that one could be touched, surfacing an insight in order to, with the right behavioral economics inspired, if you will, action, to make sure people are following and self-managing in a better way. I think that will lead to a much healthier world if that happens.
Good. Thank you. Questions? Does anybody out there have a question? This is your chance. We have just a few minutes left. No?
No.
They're satisfied with the discussion?
That's good to know.
Or they're asleep. One of the two.
Oh, forget it. What rubbish.
Okay, please. No, you bring it. There's a microphone coming. Please stand up. Thank you.
Okay. Hi. So my question is about Watson and the papers. I think it's really great application. But in science, I'm a scientist. There are good papers and bad papers. So how do you deal with that? Yeah. Human beings, we have to deal with this, so it's not a critic for your system. But as science evolves, some theories and some data, they get discarded. So how would artificial intelligence deal with this?
Yeah, absolutely. So let me give an example. Those of you who are familiar with the Jeopardy TV show, is actually that's what we did with Watson. So we pointed the system to various sources of content, knowledge, right? And based on training, so categories of questions and the answers from past shows or past contests, the machine learned what source of knowledge it should refer to with what degree of confidence for a certain type of or category of question. Same thing in medicine. So right now is, for example, some of the applications we have, we're pointing the system to expert identify sources of knowledge, right? So there is that first filter of these are reliable sources because some physician, some oncologist has suggested them. You're absolutely correct. There could be bad papers in those, even they have gone through the filter of scientific review. There are two ways. Either as new papers come in and the system is making decisions or making suggestions based on the readings of the new papers and the outcomes and the feedback loop that exists, the machine self-corrects and tends to consult with the sources that are more reliable or correct, right? That takes time. Of course, one can intervene and say, we found fault in these papers, just take this source out and the system will adapt itself as so it's a continuous learning process, and I think it has to, the bad examples will be washed out as new examples or good examples.
Sharam, forgive me for interrupting, but telling a good paper from a bad paper is pretty hard. I mean, if you say you've got filters, what are your filters? Are the filters the level of the journal, the impact factor of the journal? Because everyone agrees that that's not a good measure. It's the only measure that we have, pretty much, but it's not a good measure.
Absolutely.
So how do you say?
The machine cannot tell this is a good paper versus a bad paper.
No, exactly. So
some of the scientific reviewers also have the same problem of distinguishing. So I think, and we all have seen this as we have reviewed scientific literature. But the thing is, as time goes on and you see the examples, because some researcher, some physician is looking at the results of the machine. And the interesting thing, these are not black box approaches. What we are doing in Watson, we always point to the source document, why we are saying a certain thing, why we are recommending a certain action or suggestion. By looking at those, if the human expert finds that this is actually a faulty paper, then through that feedback, the system can retrain itself or adapt.
Yeah, I think with regard to quality of papers, there are at least two dimensions, and one of them we can handle. So one dimension is what is important, what is a big advance, and what is not a big advance. That's a difficult one. But the other one is the quality of the data. Actually, how much can you trust the data? And I think with the developments that now happen, that data are more and more uploaded to be available to everyone, they will be tested and checked by many labs much more easily. And that I can imagine that can also be done by computers. Simply check for internal consistency and check that the data are actually supporting the conclusions and so on. So that in that regard, I'm reasonably optimistic that that this can be dealt with.
Yeah, Hiraki, please.
Yeah, I mean, we could do that actually. We actually hand-curated it, thousands of papers, and then when we have all the consensus results, and then some irregular anomalies, and then you look at the the consensus anomalies. You say, go into the experimental method, and we say this is a high throughput, this is a specific experiments, or verified multiple parties, or something you have to be worry about is what are the irregularities? I mean, someone actually doing something different. And then, is this error, or is this a specific anomaly under specific condition that you need to be worried about? That's kind of hard to tell. So always keep a note on that. And a couple of times we experienced something we thought about wrong. It turned out to be true, and have a new paper coming. That was actually true. Those things does happen actually. So it's hard to tell. Deterministically, this is a good paper, bad paper, actually. There's a quality, but there's something which is written there may actually change over time. So it's only be the snapshot and the consensus, actually. The likelihood, which is likely to say the somewhat true thing or some false, I think that might dynamically change.
Well, I mean, since we have two biological scientists on the panel, I mean, three, do you think that augmented intelligence is actually a way to get at this crisis in reproducibility in science?
Yes.
Yeah. Through this mechanism that you're describing?
Also using robotics experimental system as well. So all the experiments need to be under robotics and have to be completely traceable.
Yes.
And all the data needs to be on the single platform. Yeah. And then using blockchain, whatever you want. And then first of all, it's transparent, traceable. And the reproducibility is like some of the recent robotic experiments which I'm involved with. We come up with a Nature Biotech soon. Is that if you do the robotics system to do the pipetting, and the accuracy is going to be much improved than the best human technicians. So if you do that, something we cannot reproduce, something depends on the biological variability, something depends on the subtle change in experiments that we do. So that need to be separated.
Actually, so as Edward alluded to, that is happening in certain scientific societies. So you have to upload with your paper the data that went into that study. And in studies that involve computer, basically programs, you also have to upload your code.
Yes.
So it's getting there with respect to reproducibility of science, but I mean, it's not general. It's not all-encompassing at this point in time. It's for certain societies that this is happening. Yes. And I agree with his point. Even if you take it to the lab and the robotics and reproducibility around how you conduct the lab, basically.
I mean, the one is the governance level, which is traceability and integrity. The other, the technical and the biological aspect of the variability. And I think the two things have to match to significantly improve the reproducibility.
Thank you both. Edward, do you want the last word on this?
No, I would just support what you say, but I think it's much better than it was maybe 5-10 years ago. So it's going in the right direction with regard to being able to reproduce or even check whether data actually can be trusted.
Good. Okay, thank you for the question. It was an excellent one. Oh, we're really running out of time, but quick last question, please. Yes. Lovely.
So I'm one of the panelists. So may I ask one question?
Yes.
So what you have not discussed is mental disorder, psychiatric disorder, or developmental disorders. From Dali, this is the largest economical burden to our society. And this psychiatric disorder, mental disorder, are very different from other disciplines in the sense that all the diagnostics are just based on interviewing between medical doctors and patients. But recently, neuroscience, human neuroscience based on research domain criterion or human connectome project tend to find subclasses of, for example, major depressive disorder, or they found almost orthogonal biotypes to traditional diagnosis. So what AI can do to this?
Please, Sharon.
So in our research labs, actually, we have a piece of work that is looking into this, and it's quite interesting. Is for certain psychological disorders, the human who is being afflicted by that disease or condition basically says something or get transcribed into a paragraph of text, if you will. And machine basically analyzes the relationship between concepts in that text document and the geometry of those concepts, meaning how the human speaker is jumping between concepts and the formation of those geometric patterns. And based on those geometric patterns that are composed of the concepts and the sequence of them, through AI and through machine learning, we can distinguish between different scenarios of basically mental afflictions that this person might have.
Thank you.
Of course, it's in research, but it's an interesting way to look at it.
Okay, very briefly, Hiraki, and then Edward.
Yeah, one of the things we actually trying to do is like a major pharma, preparing for clinical trial in the US on the CNS study is to bring the multi-sensor fusions, continuous monitoring, and using like a little sensors, cameras, even the mobile phones to get the data, and to get like a machine learning, because unsupervised clustering to find out the subclasses, and then associate that specific cluster into what the doctor perceives to be the specific disease subtype. And then I try to get specific, efficacy on the drug on the pipeline. So that's something, I think that's way better than the caretaker taking, survey or doctor checking up, on seat. That's way better than that.
If I may add a quick small thing. So I completely agree with large data collection, and it's actually in the area of mental health. One of the interesting things, telling information, is lack of data, not just having the data. Because if you're not recording a piece of data, that is actually more telling than if you have data about that person. I think this is a very important area to look into mental health.
Okay. Yep. The timekeeper is over time, so last word to Edvard, and we stop.
Just very quickly, but I would say that in addition to the work you are doing, I think psychiatry is going to be transformed quite radically as we begin to understand the brain, and especially the cortex, so that it may not only be guided by what the patient is saying anymore or interviews, but actually we will have biological markers that don't exist today.
Thank you very much indeed. Okay. Thank you all. Thank you to my panelists, and we'll see you after the coffee break. Thank you.
ご案内申し上げます。